Good morning, dear students. Today I am going to start new chapter, hydrogen. It is chapter 9, and you have to remember one thing, that no part has been reduced from this chapter. So everything which is given in your book you have to study. Let's start with the abundance of hydrogen. Hydrogen is the most abundant element in the universe. Some estimates are that 92% of the universe is made up of hydrogen and 7% helium, leaving only 1% for all of the other elements. However, the abundance of hydrogen in the Earth's atmosphere is very small. This is because the Earth's gravitational field is too small to hold so light an element, though some hydrogen is found in volcano gases also. In contrast, hydrogen is the 10th most abundant element in the Earth crust. By weight, if you will see, it is 0.152%, and it also occurs in vast quantities in water in the oceans. Compounds containing hydrogen are very abundant, particularly water, living matter such as carbohydrates and proteins, almost all the organic compounds, fossil fuels like coal, petroleum, and natural gas, ammonia, and acids. In fact, hydrogen is present in most compounds than there are elements. Let's see the position of hydrogen in periodic table. Hydrogen is the first element in the periodic table and is unique. There are only two elements in the first period, hydrogen and helium. Hydrogen is quite reactive, but helium is inert. There is no difficulty relating the structure and properties of helium to those of the other noble gases in group 18. But the properties of hydrogen cannot be correlated with any of the main groups in the periodic table, and hydrogen is best considered on its own. The structure of hydrogen atom is in some ways like that of the alkali metals. The alkali metals of group 1 also have just one electron in the outer shell, but they tend to lose this electron in reactions and to form positive ions M+. Though hydrogen plus are known, hydrogen has a much greater tendency to pair the electron and form a covalent bond. The structure of hydrogen atoms is in some ways like that of the halogens, since both are one electron short of a noble gas structure. In many reactions, the halogens gain an electron and so form negative ions, X minus. Hydrogen does not typically form a negative ion, although it has formed ionic hydrides. You will find the ionic hydrides M plus H minus. If I'll give you example, LiH, lithium hydride, CaH2, calcium hydride, with a few highly electropositive metals. In some ways, the structure of hydrogen resembles that of the group 14 elements. Since both have a half-filled shell of electrons, there are a number of similarities between hydrides and organometallic compounds. Thus, the hydride is often considered as a part of a series of organometallic compounds. However, hydrogen is best treated as a group on its own. Let's see the resemblance of hydrogen with alkali metals. Hydrogen resembles alkali metal in following aspects. Number 1, electronic configuration. Like alkali metals, hydrogen also has one valence electron. Electropositive character, like other alkali metals, hydrogen readily forms the hydronium ion, which is very stable. Reaction with nonmetals forms hydrogen forms sulfides, oxides, and halides, same as alkali metals. When we will see the reducing action of hydrogen, we will find that like alkali metals, hydrogen also acts as a strong reducing agent. Children, you must remember that this chapter is not at all new for you all. This you are studying from class 9th about the hydrogen. Okay, so I am moving little fast for the points which you already know. So just revise the chapter. Only little part you will find that is new, but all you have studied earlier. So revise the chapter again. Now see the resemblance of hydrogen with halogens. Electronic configuration. Hydrogen is short of one electron for stability in the outer orbit, as explained here. Hydrogen, one electron, it will become H minus. Fluorine will accept one electron and uh, fluoride ion will be formed. Atomicity, all halogens exist as diatomic covalent molecules F2, Cl2, etc. In a similar way, hydrogen is also a diatomic covalent molecule. Physical state, hydrogen is a gas like fluorine gas and chlorine gas. If we will talk about ionization potential of hydrogen is very high, same as in the case of halogens. Reaction with nonmetals, both halogens and hydrogen combine with other nonmetals by forming single bonds to give compounds like carbon tetrachloride, methane, and silicon tetrachloride. Now let's see the isotopes of hydrogen. If atoms of the same element have different mass numbers, they are called isotopes. The difference in mass number arises because the nucleus contains a different number of neutrons. Naturally occurring hydrogen contains three isotopes: protium 1H1, or we simply represent it with H, capital H; deuterium 1H2, or we can write capital D; and tritium 1H3, or we can write capital T. Each of the three isotopes contains one proton and 0, 1, or 2 neutrons respectively in the nucleus. Protium is by far the most abundant. Naturally occurring hydrogen contains 99.986% of the 1H1 isotope, 0.014% of deuterium, and 7 into 10 to the power minus 16% of tritium. So the properties of hydrogen are essentially those of the lightest isotope. The isotopes have the same electronic configuration and have essentially the same chemical properties. The only differences in chemical properties are the rates of reactions, the equilibrium constants. For example, hydrogen is more rapidly absorbed on the surfaces than deuterium, and hydrogen reacts over 13 times faster with chlorine than deuterium because hydrogen has a lower energy of activation. Differences in properties which arise from differences in mass are called isotope effects. Because hydrogen is so light, the percentage difference in mass between protium, deuterium, and tritium is greater than between the isotopes of any other element. Thus, the isotopes of hydrogen show much greater differences in physical properties than are found between the isotopes of other elements. Okay, some properties have been given in the table of for protium, deuterium, and tritium. Okay, next will be our methods for preparation of dihydrogen. Let's start with first with the laboratory preparation. In laboratory, you have done this experiment also. In class ninth, you may have formed hydrogen gas by just adding either HCl or H2SO4 on zinc granules. And you better know why we don't use nitric acid here. So that will be your laboratory method. As many times I have told to my students, the easiest method is laboratory method, and when the raw materials are cheap, the cheaper method will be our industrial method. So in the laboratory we can prepare hydrogen from acids, metals which lie above hydrogen in electrochemical series, that is, metals with positive value do not displace hydrogen from dilute mineral acid like HCl or H2SO4. Metals having negative value means metals which are lying below hydrogen in electrochemical series displaces hydrogen and from acids. For example, zinc, magnesium, iron, etc. displace hydrogen from acids. You may remember, you are studying this equation from class 7. Zinc plus H2SO4 gives out zinc sulfate plus hydrogen gas. Now see how we can prepare hydrogen from alkalis. Certain metals like zinc, tin, aluminium, lead, silicon, etc. These are all amphoteric metals. They react with boiling sodium hydroxide to liberate hydrogen. The reaction is given here, sodium zincate. When sodium will react with sodium hydroxide, when zinc will react with sodium hydroxide, sodium zincate will be formed and hydrogen gas will evolve. Now let's see how we can prepare dihydrogen on commercial scale. Hydrogen is manufactured on a large scale by a variety of methods. Number one is that hydrogen is made cheaply and in large amounts by passing steam over red hot coke. If you can remember this reaction, steam is being passed over red hot coke. The product is water gas, which is a mixture of carbon monoxide and hydrogen. This is an important industrial fuel since it is easy to make and it burns, evolving a lot of heat. You can write the reaction in your copy. Carbon plus C plus H2O gives out CO plus H2. This is your water gas, and temperature you can mention on the arrow, 1000 degrees centigrade. Okay, it is difficult to obtain pure hydrogen from water gas since carbon monoxide is difficult to remove. The carbon monoxide may be liquefied at a low temperature under pressure, thus separating it from hydrogen. Alternatively, the gas mixture can be mixed with steam, cooled at 400 degrees centigrade, and passed over iron oxide in a shift converter, giving hydrogen and carbon dioxide. The carbon dioxide so formed is easily removed from the solution, giving potassium bicarbonate and thus giving hydrogen gas. Okay, this is one of the industrial method. The other is by electrolysis of water. The water containing a small amount of an acid or alkali, about 15 to 20%, is electrolyzed in an electrolytic cell. The anode and cathode are separated by an asbestos diaphragm. The cathode is usually made up of iron and anode usually of nickel. So what will be the reaction at the anode? Hydroxide ions are discharged and oxygen is evolved. And the reaction at cathode will be hydrogen ions are discharged and hydrogen is evolved. Bosch process I have discussed. The process of obtaining synthesis gas from coal or coke is called coal gasification. From hydrocarbons also we can prepare hydrogen gas. How? Hydrogen is also made in large amounts by the steam reformer process. The hydrogen produced in this way is used in the Haber process to make ammonia and for hardening of oils. Light hydrocarbons such as methane are mixed with steam and passed over a nickel catalyst at approx 800 to 900 degrees centigrade, and these hydrocarbons are present in natural gas and are also produced at oil refineries when cracking hydrocarbons. So the gas emerging from the reformer contains CO, CO2, hydrogen, carbon monoxide, carbon dioxide and hydrogen, and excess of steam. The gas mixture is mixed with more steam, cooled at 400 degrees centigrade, and passed into a shift converter. This contains an iron copper catalyst, and carbon monoxide is converted into carbon dioxide. Okay, so finally, the carbon dioxide is absorbed in the solution of potassium carbonate, or we can take ethanolamine, that is HOCH2 CH2 NH2. This potassium carbonate are regenerated by heating. So these are few simple methods by which we can prepare hydrogen. Okay, next, about physical and chemical properties of hydrogen. I think I should discuss this in my next lecture. Okay, this much is sufficient to listen and understand in your first lecture. Okay, read it once, whatever is given in the module, listen it and try to understand it. Okay, thank you so much, children.